Welcome to SAT School. I am your instructor from satschool.com. This is our first video on HCF and LCM. Now let's get started. Before we dive into HCF and LCM, we try to understand factors. What are factors? Factors are all those numbers that can divide a given number completely. Completely here I mean without leaving any remainder, that is remainder equals to 0. Here is an example. Here 20 is completely divisible by numbers 1, 2, 4, 5, 10 and 20 itself. You can say now these numbers are factors of 20. Among these numbers there are some prime numbers which are 2 and 5. That's why prime factors of 20 is 2 as well as 5. Now the next is a multiple. A multiple is a number that is completely divisible by a smaller number. In the above example, 20 is completely divisible by smaller numbers. So 20 is multiple and smaller numbers are factors. One point to note here is a multiple is a greater number like 20 and factors are smaller numbers like those numbers 1, 2, 4, 5, 10 and 20. So what we understood here is factors are those numbers that can divide a given number completely, and a multiple is a number that is completely divisible by a smaller number. Again, a point to note here is a multiple is a greater number and factors are smaller numbers. Here is next example. We have two numbers 30 and 36. 30 a multiple of 2, 3 and 5. 36 a multiple of 2, 2, 3 and 3. Now to find HCF, that is the highest common factor, the first step is to identify common factors. Now here the first common factor is 2. We have one more common factor which is 3. Since there are no more common factors, this is the highest common factors between 30 and 36. That's why HCF of 30 and 36 is the multiple of 2 and 3, which is 6. The highest common factor is the largest number that divides two or more numbers completely. Here, the HCF 6 divides the given two numbers 30 and 36. Again, HCF is the highest common factor and the highest common factor between 30 and 36 is 6 because there are no more common factors between 30 and 36 and 6 is the highest common factor. Now to find LCM, the first step is to look at the first step is to look at the common factors between those two numbers and then the remaining factors. Now in this case, the common factors are 2 and 3 and the remaining factors are 5, 2 and 3. Now the LCM, the least common multiple, is the product of 2, 3, 5, 2 and 3. And the answer is 180. Now the least common multiple is the smallest number which is exactly divisible by each of the given numbers. Here 180 is divisible by 30 and 36. LCM is exactly divisible by given numbers. On the contrary, the given numbers are completely divisible by HCF. That means HCF divides the given numbers and LCM is divisible by given numbers. Here is a relationship among them. That is, the product of HCF and LCM is equals to products of given numbers. If you find the product of HCF and LCM, that should be equals to the product of given number 30 and 36. We have LCM, which is 180, HCF is 6, and the given numbers are 30 and 36. So their products is 1080. So this is the relationship among the given numbers and HCF LCM. In this course, we are not going to find HCF and LCM of numbers. Rather, we will deal with algebraic expressions. Now, here are some examples of algebraic expressions. 4x plus 7, 3x plus 2y minus 10, a square minus 12a plus 35. In these algebraic expressions, we have x, y, a as variables and 10, 7, 35 as constants. So, algebraic expressions are made up of variables and constant as well as algebraic operators or mathematical operators like addition, subtraction. In this course, we will find HCF and LCM of these types of algebraic expression. Here's the first practice question. Two algebraic expressions are given, fx and gx. Now, if their HCF and LCM are px and qx respectively, we have to show the relationship among them. As we already discussed, the product of HCF and LCM is equals to product of given numbers. In this case, the product of algebraic expression. Now we can show the relationship among them. Here, LCM and HCF are given, which are Px and Qx, and given two algebraic expressions are Fx and Gx. So HCF is Px, LCM is Qx, and given two algebraic expressions are Fx and Gx. And this is how we show relationship among them. This is practice question number 2. We have two expressions x minus y and x plus y. Now the question is to find HCF and LCM. Here the first expression is x minus y. That is the algebraic expression and we simply write first expression. Second expression is x plus y. Now to find HCF, that is the highest common factor, we look for common factor. Since x minus y and x plus y, they have no factors in common, the HCF will be 1 because 1 is multiple of every factor. Point to remember, if there are no common factors, then HCF is always 1. Now to find LCM, the first step is to identify common factors and the second is to look for other factors. Now here is no common factor. LCM is equals to the multiple of x minus y and x plus y. Again, a point to note, if there are no common factors, HCF is always 1. Here is practice question number 3. We have to find LCM between P, P minus Q and Q, P plus Q. Here the first expression is P, P minus Q and second expression is Q, P plus Q. Now to find LCM, the first step is always identify the common factors and the next is to identify remaining factors. So here are no common factors, that's why LCM will be equals to PQ, P minus Q and P plus Q. Now these are some important formulae or formulae, whatever you say. As we go on, we will discuss some more formulae. The first is a square minus b square, that is a minus b, a plus b. Similarly, a plus b whole square, a minus b whole square, a cube minus b cube, and a cube plus b cube. As I said, as we move on, we will discuss some more formulae. Now, let's use them in our question. So, here is practice question number 4. We have to find HCF and LCM between x square minus y square and x plus y whole square. The first expression, x square minus y square, is in the form of a square minus b square, which is equals to a minus b, a plus b. Here, the first expression is x square minus y square. Now, you can write here x minus y, x plus y, because that is in the form of a square minus b square. The second expression is x plus y whole square, and you can simply write x plus y, x plus y. Now, to find HCF, the common factors between these two algebraic expressions is x plus y. So you can find x plus y in the first expression and x plus y in the second expression. Now, if x plus y is a common factors, the remaining factors are x minus y from the first expression and x plus y from the second expression. That's why the LCM is the first common factor, x plus y, and the remaining factors, x minus y and x plus y. Now you can simply write that equals to x minus y and x plus y whole square. Now this is practice question number 5. Here you have to find HCF and LCM between x cube minus y cube and x square plus xy plus y square. Here x cube minus y cube is in the form of a cube minus b cube, which is equals to a minus b, a square plus ab plus b square. So I want you to try this problem. I hope you could manage that. So this is the end of the video for today. I'll meet you in next video. If you like the video, don't forget to subscribe. I'll meet you in next video. Take care.